Hello, welcome to the lecture series on Control Systems Engineering. Now let us continue our discussion on root locus plots. Here, I would like to demonstrate or solve some more examples. Okay, root locus examples here we will take. Right, in this example, we have ks plus 1 divided by s into s plus 2 s plus 7. There is not much of a special in this. Suppose the root locus ends at this 0, and here between these two poles there is a breakaway point. This breakaway point, it is zeta is equal to 1. Other points, you know that zeta will be different, greater than 1. And here zeta 1 point, it is a critical, there is a breakaway point. They break and they go like this. So that's a thing, not very special in this example. Here there are 3 poles at the same point, minus 1. So 0 here, at minus 1 there are 3 poles. Like this. There is a 0 at minus 4. We have to visualize there is root locus between these two poles and the root locus between this pole and 0. So you will get a breakaway point here at minus 1 only. That is the whole speciality of this problem. Otherwise there is nothing different. Okay. Draw the root locus plot for the system whose open loop transfer function is given. Show that the system is unstable for all values of k greater than 0. Then introduce a 0 at s equal to minus a. A can be anywhere between 0 to 2. Show that the system is stable for all values of k greater than 0. Okay, fine. First let us draw the root locus. You get the root locus like this, correct? A square. There are 2 poles at the origin, so obviously there is a breakaway point here, and the root locus will go like this. For all values of k greater than 0, it is unstable. Here k equal to 0. Okay. Now let us solve this example introducing a 0. That is s plus 1. Now the root locus plot you can see here. For all values of k, the root locus is on the roots are on the left hand side of s plane. So system will become stable. So that's all we have to show. Okay, done. Okay, it is just a study. B and A are given. A equal to 10, A equal to 9, A equal to 8, A equal to 3, A equal to 1, keeping B equal to 1. You go on drawing the root locus and you can make comments based on that. Okay, it is keeping A equal to 10. This is how you get the root locus. 9 you will get the root locus like this. 8 you will get this. Okay, 3 you will get this. For 1, these two get cancelled, so you'll simply, it will break on the imaginary axis only. You will find the root locus. That's it. Now here I have given a quadratic equation. You are going to get complex open loop poles. So if I do this minus 3 plus or minus 2j, you will get. So now see here, if I draw the root locus, sigma j omega, there is a pole at origin. There is a pole at minus 3 plus 2j. Say minus 1, minus 2, minus 3. 1, 2. You are having here. There is a 0 at minus 4. Okay. You will have root locus from here to here. It starts here, ends at 0. Please remember here k equal to 0 and k equal to infinity. There are 3 poles, 1, 0 means there will be 2 asymptotes. You have to find intersection of asymptote. Intersection of asymptote. If you calculate, you are getting minus 1 here, minus 1. Angles will be 90 and 270. Okay. Now, these are 2 asymptotes at minus 1. Okay. Now the speciality of this, no breakaway point here. Correct. In this example, now we have to find angle of departure, delta. A point to be on root locus, it should be 180 minus sum of pole angles you make it. Join this point like this. Join like this. And join like this. Let us say theta 1, theta p1. Let us say theta p3. And this you call it as theta z. Minus theta p1 plus theta p3 plus theta z. Measure these values, substitute, you will get delta value. There is no breakaway points. Look here. You get this, you will get 7 degree, plus 7 degree. What it means is, draw a horizontal line from here, measure 7 degree, draw a line here. If that is plus 7, it should be minus 7. Like this. Okay. Now then next is you find k values and omega value. Then draw the root locus. What happened? Point pen, ink color red. Like this. Along this line you draw. And this is your asymptote. Along this line you draw. That is a speciality. Angle of departure is the speciality. All the calculations remain same. Okay, that is the thing. Yes, sir. This in complex poles you come across this. another example for complex pole. You can see here is equal to 0, 1, minus 1 plus j, minus 1 minus j. Now breakaway points. Now you can find angle of departure delta is equal to 180 minus theta p1, means join this line and get this angle, and this is 90 degree. So minus theta p1, you want to call it as minus theta p3. Substitute those angle and you'll get minus 45 degree. So draw an horizontal line, measure minus 45 degree. Here plus 45 degree. So draw one line. So now when you are drawing the root locus along this, it should go, then it should become asymptotic. Okay, that's a speciality, angle of departure. Okay, same thing. Okay, right, not very special. Here also so. Here, the interesting part in this problem is your pole here, your pole here, your two complex poles here, correct? Okay, breakaway points, if you find out, you will get here, this root locus here, you will get a breakaway point here. And if you find angle of departure, you will get minus 90 degree. And here you will get plus 90 degree angle of departure. So from here, it will be coming from here. This will be going up. These two will break. One will go up, one will go down. Again, these two face each other. You'll get a breakaway point here and a breakaway point here. So then these two will break, go asymptotically like this. Very interesting example. Right? Okay. So let us see the breakaway points. You see here, you get this. That is the interesting part of it. And angle of departure. What is the angle of departure? I have not calculated angle of departure. Anyway. Okay. Yes. These are some of the complex problems you get like this. Right, fine. Here the whole value is you are getting 2 omega values. Conditionally stable. Okay, there are 2 k values you get. So that's the reason why it will split like this, go through this and again go through this. Here you have 1 k value and 1 omega value, k value. Only in this region, roots will be on the left hand side here. For these k values, system will be stable. I think when you calculate the k value, you can see here. We are getting 2 k values. So for one value of k, you are getting omega this, another value of k, you will get this. Right. So these are some of the interesting examples in root locus. I advise you to practice these examples so that it will become easy to draw root locus of such complex problems. Thank you.